Okay, so we're going to look at the second example, which this is the kind of problem where using your calculator is going to be absolutely essential. And that's because if you look at it, you can notice that this y-intercept is a really, really ugly number. 17 divided by 3 is a repeating decimal that I don't want to deal with. There's no way I could figure out on the graph where exactly 5.6 repeating would be, which is why we're going to use the calculator. I'm going to use the calc to get plottable points. And when I say plottable points, I mean points that are whole numbers that I can clearly plot on a graph. So, and whenever you're in any of these modes, if you hit clear, it doesn't always take you out of where you are. Like if I'm in the window and I'm hitting, I don't want to hit clear there. Or if I'm in the table and I hit clear, it doesn't get me out of there. Don't freak out. That's where you use that second in mode button to quit. Remember, second mode to quit. So I want to start by graphing my equation, my new equation, my example 2. And to do that, I'm going to hit that y equals button. Now this time I want to clear out what I have in there from before because I don't want to look at two lines at the same time. That's confusing for now. And remember, fractions in parentheses. So negative parentheses 2 divide 3, close parentheses for that x. You're using that variable button next to the alpha. Minus, and that 17/3 should be in parentheses also. Okay, so I can hit graph to get a visual of what that equation should look like when I'm graphing it. And then, again, to get those plottable points, do the second in graph button to get to the table. So just like before, we're going to ignore any of the decimal points because I can't find negative 6.3 repeating on the graph. It's too difficult. So only focus on the whole number points that fit on your graph. So I can see I have 2 negative 7. That would work. I have 5 negative 9. And then I'm going to go in the other direction because my graphs usually don't go up to 11. So remember, you can use these little arrows to keep scrolling in either direction. I'm going to use that negative 1, negative 5. And 3 plottable points is decent. So those are my plottable points that I would use to graph it. And then we're going to calculate the x-intercept. And remember, I could do this algebraically. You could find the x-intercept algebraically by plugging in 0 for y and solving for that x. However, I'm going to show you how to make the calculator do that for us. So to find the x-intercept, it's that calculate button. So you need to hit second and trace to get to that calculate option. And when we're talking about x-intercepts are the second choice, or zeros. And so now, remember, left bound means it wants to be to the left of where it crosses that x-axis. And if you ever can't see it on your graph, that's where the zoom feature would come in, where you could zoom out. So then it would be a heck of a lot easier to get to the left-hand side of that equation. Oh, I have to redo calc because I X'd out of it. So once I hit the zoom, it took me out of the calculate option. So I have to go back to second trace, choose my calculate of 0. So now I can see it says left bound again on the bottom. So I know I'm in the right place. So I am to the left, and now moving it to the right of that intercept. Boom. Enter. Guess. Yes, I want it to guess. And there we go. I've got a 0 of negative 8.5, which is something that's really hard for us to tell just by looking at that graph. I can see that it's somewhere in between that 7 and 8, but I can't tell if it's 0.5, 0.4, 0.45, 0.444, or whatever. So there we go. We got plottable points. We calculated that intercept. That calculator is going to be super helpful for you when you're looking at this unit.